MassOD here.
Hi guys, this is Dimo from MassOD.
Okay, in this session, we want to talk about a feature which is not very dedicated to the Kotlin itself. A lot of other languages out there have this feature, and this feature helps us to prevent a lot of specific problems, specific exceptions that happens most of the time, which is the null pointer exception, which most of the time dominates our program. Most of the time when you track your problem, you see that there is some kind of null reference that you are calling a function on that, and it is causing null pointer exception. And this feature, which is called null safety, will help us to not to prevent it 100%, but make it more possible. Less possible to happen. So again, I'm going to start with the Java side, because I don't want you guys to. This is not necessary to know anything about Java, but I'm using Java because to compare and show the difference, because there are a lot of features that Java doesn't have and is implemented in the Kotlin, and one of them is the null safety. For example, if we define a string and we, for example, give the title of name, now we have defined a placeholder, a variable of type string, that we can assign string values. For example, I can assign like this. And also, I can assign null. Yes, I can assign null value. In fact, even I have not instantiated it here at the first line, and it is null. So now, for example, if I say name dot, for example, length, I'm calling a function on this name. I'm trying to call a function. Even if I don't assign null to it, even if I don't assign it, for example, I pass this name to some other class, some other function, and it will be used somewhere else. And that class doesn't have any clue that if this name has a value, is referencing a valid value, or is it at null, a null pointer exception, and null. And if that class, the receiver, use this name without checking for nulls, so it will be maybe at some point of the exception that the programmer hasn't seen it before, will cause null pointer exception. And so here, for the user, inside the Java code, you see a lot of ifs above of the calling functions. For example, you most of the time have name not equals to null. You're checking for not null. You're telling that, okay, if this name is not null, I'm going to do this. So hopefully inside the Java code, you see a lot of if statements which are checking for null. Yes. And another thing that will bother here, for example, let's say we have name dot, I'm going to call a function on this name. For example, let's call a function which returns string, like strip, for example, or yes, strip. So I'm calling a function on this name, and again, I'm chaining the calls. I'm calling another thing on this. I'm calling, for example, this time for example, concat with something else, and then I'm calling dot length. So name, now the name might be null, yes? If the name is not null, then the returning value of this might be null. Then the returning value of this, and so on. So for doing this inside Java, to do it safely, you have always to do something like this. You have to say if name not equals to null, then and like this, and name dot strip not equals to null, and or you chain the ifs like this, name dot strip not equals to null, and you chain all the if statements and then call that last length on that to actually prevent from null pointer exceptions. But now let's go to the Kotlin. Let's go to the Kotlin side. In this side, for example, I'm going to define this variable of type string, name of type string. Now, if I want to assign this value, for example, I'm assigning a value to it. Now, if I want to assign null, you can see that it is complaining and saying that null cannot be a value of non-null type. So here in the Kotlin, all the types are non-null. This string is non-null. You cannot assign null value to a non-null type. So if I say, for example, now I can safely, because I know that this name is of type string, I can safely call, for example, length on that. Now, if I want to be able to assign null values to this name, I have to append a question mark at the end of the type to make it nullable, to allow null values to be assigned. So now because the name is nullable, I can assign null.
That's risky, yes, huh?
Yes. This is like, now it is becoming like Java.
You yourself should be responsible for that.
Yes, of course. The Kotlin says that the programmer should explicitly tell us that you want it to be capable of holding null values. Now we are explicitly stating that name can hold null values, can have null values. So what happens if I, for example, call a function on this nullable reference? Even if I don't assign null value, let me just bring it outside of the main function because we have some. Okay, and now just it is complaining because it is saying that property must be initialized. You cannot leave it uninitialized. Now because
you make it nullable.
Because it is nullable, I can assign null. Yes. Right away. Now I have assigned some value, but now I'm calling this length on this name. And theoretically, you can see that this name is not null, and there won't be any null pointer exceptions because now name has some value in it. If I run it, there won't be an exception. But it is complaining. It is saying that smart cast string is possible because the name is mutable. Just don't worry about the detail there. It is complaining that name might be null, and the compiler is not allowing me to compile. It is not compiling at the compile time, not the runtime. It is preventing and it is forcing me to do something about it. So what are the options here with the nullable references?
Again, using if clauses.
Yes, the first one is using if class. If I check if name not equals to null, it should work here. I don't know. I know why. It's because that name is defined outside of this function, and it might be null between the checking and using it. Because if the application is multi-threaded, for example, you are running on one thread and you are checking for null, but before using it, you are being stopped and the second thread kicks in. The second thread assigns some null value because it has access to that name at the top, and then it stops and you resume because you have checked and you are inside the if. You call the function, for example, length or something upon the name, and it will throw null pointer exception, and that's the why. But if you bring it inside here, you can see that.
That's okay.
Yes. It is okay because the Kotlin compiler is very smart, and it is seeing that in between I have not assigned any null value. As you can see, if I assign null value, it is not complaining. But it is not always the case because name is being defined inside this same function. It is actually following the steps, and here it is coming to conclusion that it can be null here. If I check for null here, if I say name not equals to null, now it is not complaining anymore. It is safe, and this by this the Kotlin is forcing the programmer to to see these situations, to see these possibilities, and be forced to check for all null pointer exceptions, and make it less possible by forcing if. Another option with working with the null values is the safe call, not safe cast. Safe call. Safe call is an operator question mark dot. Question mark dot is the safe call, and the name speaks for itself. We are safely calling some function on the nullable reference. So what will happen if the name be null?
If the name be null?
Yes.
It will have an error.
No error will be happening.
Here?
Yes,
in
here.
this case with question mark?
Yes, with question mark.
So maybe it assigns something
by
default.
It will return null. When you are...
But not, it doesn't cause an error.
Yes, it won't cause any error. For example, let's say I'm calling some other function like concat. Let's say we have...
Somehow it makes null as a string.
Yes. Let me see. We had a concat function that I'm not seeing here. Okay, for example, to uppercase. And what's the problem here? We have two uppercases, two functions, two overloaded functions. Let's see, the strip is to lowercase. We have, what is happening? Overloaded, resolution, ambiguity, all these functions match. String. Okay, for example, I'm calling this plus function on the name, and then it is returning also an string. Then this here, this whole expression here might return null because the name might be null, and this safe call might return null for the whole expression. Then if I call dot, for example, on the chaining string and call other function like again plus, let's see, because it's defined on a nullable value. Let me call other function which is not defined on the nullable. For example, let's see if we have reversed. Yes, reversed. Reverse will reverse the string. Now you can see it is complaining right at here, not here. It is complaining that only safe or non-null asserted call is accepted here. So again, I have either to check this part to see if it is not null and then call this on that, or again chain it with another safe call. Now, for example, if name is not null, this plus will be called on that. But if this is null, then null will be returned from this expression.
Whole expression.
Yes. Now, if it is not null, the reversed will be called on that, will be called on the result. And if the reversed is null, then again the null will be returned. This will help a lot, in a lot of situations. You'll see, for example, if you've programmed in Java, you see a lot of if statements, chaining if statements that are checking for null for something in this third level inside an object. Another option with working with the nullable values is the Elvis operator. The Elvis operator is a question mark and a colon.
Can you comment the names on top of each way?
Okay, this one is safe call, and this one is Elvis. So the Elvis operator is a simple one. It has two operands, one on the left and another on the right. If the operand on the left be null, then it will return the thing that is on the right side of the operator. For example, if name is null, if name is not null, it will be returned. But if it is null,
it will return the right side.
Yes, it was null, for example. It will return what is in the right side.
That's
Now-
a kind of if clauses.
Yes. Now if I assign it, for example, to some kind of a string, for example, a result, this is string. You can see that this is a string, not a nullable string.
Mhm.
It is a safe, not safe. But if I, for example, get rid of this part, comment it,
It will have consonant.
yes, it is saying that required string, but
Mhm.
found nullable string.
That question mark means no.
Yes. Now this helps to return, for example, and this is an expression. It could be used anywhere inside if and anywhere. And the last one here is null asserted call, or this one is that they call it to shoot. If you want to shoot yourself in the foot.
Foot.
If you want to shoot yourself in the foot,
Mhm.
you can use this operator, this next operator, because all this that we explain is for preventing nulls from
Mhm.
happening. But for example, at some point, you might be sure that at this point of the application, this name is 100% not null. Then you say name two bangs, bang bang, two exclamation marks, dot. Now this, for example, you can call reversed. And you can see that I can assign it to the, let me make it var, the result. And it accepts that. Here, this operator here, if the name is null, then a null pointer exceptions will be thrown.
Mhm.
This is like the Java, this is like you are defining something nullable,
Mhm.
and then every time you are using it,
Here we will have error.
yes, every time you're using it, you are explicitly saying that it's Kotlin, it's none of your business. I want to call this function on that. I don't
Mhm.
want you to complain or don't compile, just
Mhm.
compile. And you're accepting the
I'm
consequences.
sure about that.
Yes,
That's not null.
maybe you are sure, maybe you are not, but you're
Mhm.
accepting the consequences here. So this is like Java. This is like Java. Inside Java, everything is nullable, and all the calls are null asserted, all of them. So this is pretty much everything about the null safety feature in the Java, in the Kotlin, sorry. And I know that the Dart null safety is Dart language, which is the Google language, is in the alpha or beta phase, and it is almost the same as the Kotlin null safety, or we have null safety in the C#, and but we don't have null safety inside the Java programming language.
Unfortunately.
Yes, but with the Kotlin, you have it from from the day one.
Mhm.
After some time, you will get used to this null safety thing, and you will define everything not being null. Not nullable. You will define everything as not nullable. Now, one thing to mention here, as you saw before, I defined this. Let me bring it out. I defined this name. When I define this name outside of the function, not as a local variable, it is complaining here that it must be initialized. But with the Java, it's not the case. You can define a string here, and it won't
Without
won't complain.
Mhm.
But what is the initial value inside the n here?
Nothing.
It's null. It's null. It will initialize null on our behalf.
Mhm.
But with the Kotlin, because the string cannot be null here, it is actually forcing us with initializing with some value. So we should give some initial value here.
But in Java, if you want to compare it, it will say that you should initialize it.
Here, no. If you define it as a local variable, yes, it will complain that please first initialize it. Now
Mhm.
that I deleted that, you can see that the name.
But not in global.
You can use the global one here, for example, n dot
Really?
string.
Okay.
Yes, it won't complain.
Mhm.
No, this n is defined inside this class, and I should create. Yes, it is not complaining. I should instantiate an object to access this n here, or I can make it static. Let me make it static. I don't want you to get overwhelmed with this creating object, I just want you to focus on the null safety feature here. So, so with Kotlin, you must initialize it right away, or there is some other option. Sometimes you don't have the value, the first value, initialized value, at the moment. You can define, if it is val, you have to give the value, you know, right away.
Initial.
You have to initialize it. But if it is var variable, you can mark it as late init, saying that it will be initialized later. It will be initial, but it cannot be null. Name cannot be null, and at the moment it doesn't have any value. And if you call, for example, if you say name dot reversed, it is working. It is not complaining because it doesn't have any clue whether or not it is initialized or not. And it will throw an exception here. The exception will be the name is not initialized. It won't be null pointer exception here. You can complain that, okay, what is the difference? I can define everything as late init and then use it like the Java. But we have a difference here that you cannot assign null values to non-nullable types. And also the exception differs here, and you will, for example, see that, okay, I've made mistake here, then I should initialize it somewhere here to make it work. But again, it will prevent you from assigning null values. And yes, by this feature, you will have less buggy programs, and null pointer exceptions will be happening and occurring, you know, less, hopefully.
Very good. Thank you very much. That was useful.
Okay. Don't have
Thank you.
questions.
Don't forget to subscribe.
Yes.
Bye.
Bye.